it's hard to go after Sharon. Oh my God. I have to say, I have no singing, no dancing in my presentation, so I feel terrible now. What am I going to do? But Hamish mentioned serverless and microservices just before, and let's talk about that a little. So at the end of March, the Amazon Prime Video team, and I think some of you know that I will address this topic, published a blog post titled "Scaling Up the Prime Video Audio-Video Monitoring Service and Reducing Costs by 90%." And there was a little subtitle there. The move from a distributed microservices architecture to a monolith application helped achieve higher scale, resilience, and reduce costs. And as you can imagine, a blog post from an Amazon company with that kind of heading and message caused somewhat of a stir. There was a whole lot of drama on Twitter with people that I really respect offering completely opposing points of view on what had happened. It was wild for a few days. It was maybe more wild than when Hamish goes out on Saturday night. I don't know. The post appeared on Hacker News, and if you are familiar with Hacker News, there was a lot of very colorful commentary there as well. Now, if you haven't read the blog post, if you haven't followed what happened, I just want to tell you briefly what was said. And if there's anybody here from AWS in the audience, and I can see Derek, hi Derek, and if you're suffering from PTSD induced by this post, I want to apologize. I'm so sorry. I will buy you a drink after this, I promise, okay? Thumbs up, excellent. All right, so let's do this. So the blog post written by the Amazon Prime Video team basically described a service that they had built for monitoring the quality of every video stream viewed by every customer. The service allowed Amazon to identify quality issues and like block corruption or syncing problems, and then trigger a process to fix those issues. So the initial version of this tool had three main components. There was a component to convert video streams to frames or decrypt audio buffers. There was an algorithm to analyze frames or audio buffers looking for corruption. And finally, a component for sending a real-time notification if a defect was found. And so the initial architecture was built using step functions and Lambda. And you can kind of see the high-level design on the screen right now. Now, the author of the blog post wrote that using step functions and Lambda and S3 was a good choice for building the service quickly and getting it out to production. However, they soon started hitting scaling limits at actually only around 5% of the expected load. And furthermore, the cost at a large enough scale became way too high. And so a couple of things to note about this architecture. The blog post states that the bottleneck was the orchestration management using step functions. Because they had to perform multiple state transitions for every second of the stream, they quickly reached account limits. And it was also costly because AWS charges per state transition as well. Next, the system was passing individual frames, basically think static images, between different components. They actually built a microservice to split videos into individual frames and then upload those images to S3. Now, the defect detectors, and each defect detector was a separate microservice, would grab frames from S3 and process them concurrently using Lambda. Now, imagine the scale on that, breaking every video stream into frames, saving those frames into S3, then having multiple microservices get them out from S3 again and process them in parallel. And I bet that people who are familiar kind of with the serverless approach to software development kind of had a bad feeling as they were reading through the blog post. Anyway, here's what the team did next. They re-implemented the serverless microservices architecture into what they called a monolithic application. In reality, they basically containerized the application and began using ECS. So they packaged nearly everything into a container and eliminated the need for S3 as that intermediate storage for frames. Most of the data transfer was basically now happening in memory within the container. At a high level, the three main components in terms of the application logic remained the same. So this allowed the system to this allowed the team to migrate the system relatively quickly. The team also had multiple fault detectors, and they wanted to add additional ones. But that could potentially kind of exceed the capacity of a single EC2 instance. So what they did is that they cloned the detection service multiple times and ran each copy with a different subset of detectors across a pool of EC2 instances. And finally, they implemented an orchestration layer kind of to distribute customer requests to different ECS clusters, running different defect detectors, as I just mentioned. Now, the takeaway that the team had was that moving the system to a monolith, and again, they are calling it a monolith, and I think we can really argue kind of the naming here. Well, they said that it cut costs by 90% and increased scaling capabilities. Running containers on an EC2 via ECS also allowed them to take advantage of EC2 compute savings plans. And as you can imagine, this kind of a blog post, moving a large chunk of the system from step functions and Lambda to a container, resulted in quite a conversation. And I remember having a number of thoughts as I was reading through the blog post. And by the way, this is apparently me. I'm thinking and using quite old computers, and I'm very young in this made-up image. I always recommend going serverless first, and then experimenting with other solutions if that doesn't work. And it's important to obviously understand how the system will scale, right, and what it is designed to do. I wouldn't recommend using a serverless system, say, for, I don't know, sustained ML inference training, right? At least at this stage, it would be too cost prohibitive. But I think the best analysis of this whole thing came from Adrian Cockcroft of Netflix and AWS fame. So Adrian wrote a blog post which was titled, "So Many Bad Takes, What is There to Learn from the Prime Video Microservices to Monolith Story?" And his take was that the original approach that the team took was entirely correct. They wanted to get something up and running quickly. They tried the serverless approach first, fine, and they succeeded, okay. They got to market and had the system running in production. Then when they tried to scale and cope with high traffic, they realized that some of the steps in the step functions workflow were too frequent, and maybe there were too many calls between Lambda and S3. So they packaged everything into a horizontally scaled microservice running on ECS. Now, one problem that Adrian notes is that the blog post kept saying that the system went from a microservices architecture to a monolith, when it was clearly just a microservices refactoring step. And I must add that this is why having clear definitions is very important. What is a monolith? What are microservices? Are we all talking about the same thing? Because at least in my mind, a monolith is something very different to what the team was describing in that blog post. Adrian also wrote that he's always recommended that if you need to process sustained traffic at a low latency, then your serverless prototype should be re-implemented as a continuously running autoscaled container, which is part of a larger serverless event-driven architecture. And he mentioned that if you tried to build it like that from the very start, it would probably take you longer, because you would need to make a lot more decisions on how to build it, how to run it. You wouldn't be able to iterate as quickly. So yeah, according to Adrian, Amazon didn't really get it wrong. They actually followed what he thinks is best practice. And this isn't really some return to the monolithic architectures of yesteryear. He does think, though, that microservices have actually been oversold as an answer to everything, particularly when it comes to Kubernetes. And he's got a few choice words about Kubernetes as well. So that's a very fun read. If you get a chance, check out the blog post. I thought it was excellent. And there were two reasons why I was interested in this whole story, really. The first reason is this. A few years ago, I attempted to do something with video processing as well. It was a really interesting proof of concept, which worked. I implemented my project. I wrote and gave a talk at Serverless Conf New York. I published a few blog posts, a chapter in my book. And admittedly, my project was a lot smaller in scope. All I wanted to do really was transcode a video from one format or resolution to a different format or resolution. And my approach was kind of similar. It was to divide and conquer, to parallelize the steps as much as possible, and hopefully solve the problem quicker than with a traditional approach. So how would you transcode or encode a large video file, take it from one format to another? Here are just general steps at a high level. First, you have the original file. Then you can split it up using Lambda. Then you can transcode each smaller segment or each smaller portion in Lambda, and hopefully you can do this in parallel. Then you can begin to merge the new segments which you have transcoded. And finally, you produce a final video with that different encoding or bitrate. And here's an architecture diagram that I implemented using step functions. I'm not going to go through the architecture with you, but if you are interested, please have a look at the blog post. It basically explains everything in detail. One thing that I should mention is that I was splitting videos on keyframes rather than every frame. And then I encoded every kind of smaller segment or portion of the video using FFmpeg running in Lambda. That happens in memory, and then the resulting file is saved to S3. And breaking up videos on keyframes was really a strategic approach, kind of between being able to parallelize the operation and at the same time not creating like a million 1-second segments of the video. So there's a balance in there somewhere. And look, step functions has its quirks. I love it, but at a certain scale, it will become pricey. So if you like standard functions, but think pricing could become a concern, there are also express workflows for step functions. They are cheaper and have a higher throughput. They have certain limitations, like they only run for a max of 5 minutes versus 1 year for regular step functions. And they also have at least once execution guarantee versus exactly once in regular step functions. And incidentally, when I built my prototype a few years back, I benchmarked the results on a bunch of video files from small to large. And you can see that the serverless Lambda approach is actually faster in all tests but one compared to running FFmpeg on a regular EC2 instance, and I think I used T2 back then, or running on my MacBook Pro. And you can kind of understand why. Because serverless Lambda can process in parallel at a great speed, while a more traditional approach, if you just encode a video file, happens sequentially in serial. And so even though the hardware is faster, the overall process is slower. So the point is, to be honest with you, if I was going to implement this for a high volume, high scale, constant throughput situation, I probably would not do it this way. It would probably become too expensive to run. This idea is excellent for something small. It is not excellent for large workloads. And I think this was kind of evident years ago, to be honest. Instead, I would explore an off-the-shelf system like AWS Elemental Media Convert, although it would also probably become too expensive. So then I might explore the option of, say, running FFmpeg in a container, doing the encoding, and then saving to an S3 bucket. The point is that you need to use the right tool for the right job, and I think we all talk about this all the time. Going with a pure serverless approach is right for some situations, but not a silver bullet. Maybe running code in a container is better. And there shouldn't be a dogma to what we do, right? What's important is being able, of course, to think through the requirements, the architecture, and to articulate why you're making a certain design decision. And you know what? You won't always get it right. I definitely haven't gotten a lot of things right. Sometimes you will build a monolith and then transition to a serverless approach. You may go back the other way. At A-Cloud Guru, we built a serverless monolith, and then over the span of a few years, we transitioned to a serverless microservices approach. And we did that because we had to evolve our architecture to our requirements, to our growing user base, and the internal team structure. And finally, this idea of kind of using divide and conquer and employing Lambda as a supercomputer is not a new one. A few years ago, this paper was released at the Usenix Symposium on Networked Systems Design and Implementation. And it showcased a real video encoding system running in Lambda. So what the authors did in this paper was far beyond anything that I had accomplished. So for one, they designed a full framework to run general-purpose computations in Lambda. The system they created would spin up thousands of threads in Lambda and manage inter-thread communication. Very interesting. Another thing that they did was implement a brand new video encoder to take advantage of the fine-grained parallelism given to them by Lambda. On the other hand, I just used FFmpeg, really. But look, it's OK. You don't need a PhD in computer science to build something cool. You have a supercomputer called Lambda under your fingertips. Just be aware of the power and the cost. So look, enough ranting about serverless and architecture and video processing, at least for a few minutes. I want to say hello and express how excited I am to be here for Latency Conf today. My name is Sbarski, as Hamish had said, thank you. And I am genuinely touched to be entrusted to deliver today's opening keynote. Thank you to the organizing committee, thank you to Hamish, Sarah, everybody else for inviting me to give this keynote. Thank you to all the organizers for putting on this wonderful event. I am excited to be in Perth and to talk to you. Now, I have spent a lot of time thinking about what kind of a keynote I should give today. Usually keynotes are full of inspirational stories, big ideas, visions for the future. But I want to try doing something different today with you, as you have seen. I want to draw on some of the work that I have done over the past years, and then tell you how I build my software today. I have a few rules, a few shortcuts, a few patterns that I follow. And maybe this will inspire some of you. I don't know. This is an experimental keynote for you and for me. So I don't know. Let's see what happens. But yeah, before we begin, let me just quickly tell you who I am. So this is me. I'm an AWS serverless hero. And I always say that means that I talk about serverless and AWS just too much. I wrote a book called Serverless Architectures on AWS, and these are the covers. I've been very fortunate to have the book translated to Japanese and Mandarin Chinese, and I make another joke that obviously because I don't speak those two languages, the books could say anything, so who knows. Actually, second edition has come out. That's the end of my sales process right there. I am a co-organizer of the Melbourne Serverless Meetup, so if you are ever in Melbourne, please let me know. We'd love to have you over. And I was a co-organizer at the recent Serverless Days ANZ conference. The videos are up on YouTube, so if you've missed it, please come and, please have a look on YouTube. Previously, I worked for A Cloud Guru. I had a number of roles over 6 years. I was VP of Eng, I was VP of Content, and then finally, VP of Education and Research. And I used to organize a conference called Serverless Conf, which was all about, surprise, surprise, serverless. Now I am a co-founder of an AI incubator lab based out of Melbourne. I have founded this AI incubator with Sam Kroonenberg, and we are working to release our first product. We've called our incubator lab Hot Hands. And look, I know that AI is in vogue these days, and everybody's jumping on the AI bandwagon. My God, it feels like crypto and 2019 or something. But here is what I want to say. AI is not the point for us. What we want to do is create incredible products that have a beautiful, wonderful, magical user experiences. We want to get to a level of user experience which has not been possible before. And I think that with the power of cloud computing, automation, machine learning, AI, including generative and non-generative AI, yes, including LLMs, we can create something special, and that is the aim of our incubator. Oh, there's the little logo. Nice. So I want to take you briefly to the start of 2016. This was the year that I joined a scrappy little startup called A Cloud Guru. I was the first full-time employee. There were just 3 of us, 2 founders, myself. And this startup was in the business of creating video courses about AWS, and it was a purely serverless company, as Hamish has said. Being the first full-time employee, I gave myself the title of VP of Engineering. It's a great perk being the first. And started working, building out the platform. And the initial platform, I don't know if you've heard the story, but it was kind of impressive. You could watch video lessons, you could do quizzes, you could buy courses. It kind of had all the expected bells and whistles that good e-commerce platforms have. Scaling was interesting. I remember, I'll also tell this story. I remember Black Friday 2016. We did something like 40 times the amount of transactions that we would normally do on any other day. And the platform on Lambda just scaled wonderfully. We kind of just sat there watching it. It was like magic. We didn't have to do anything else. And like I said, it was all serverless. It was service-full, meaning that we used a number of third-party products. To avoid re-implementing common functionality, we used Auth0 for authentication. We used Stripe for payment processing, which I'm sure a lot of us do right now. And as we grew, we kind of realized that we needed to evolve our architecture. So around 2017-18, we decided to move to a microservices style architecture away from the serverless monolith that we had. And our serverless monolith was basically a Firebase database with a whole bunch of Lambda functions. So the big driver for it was actually our team structure. Kind of as the company grew and we brought on more full-time development teams, the architecture had to grow with it. And moving to a microservices allowed us to achieve acceleration with having kind of highly focused teams own parts of the platform. So we had a team accountable for the student experience, for the business experience, for exam taking, for e-commerce and so on. And you can see in this diagram that we implemented a GraphQL-based approach where we had a GraphQL library hosted in Lambda behind an API gateway. This was like before AppSync and today's services. That endpoint could query multiple microservices, which were just collections of Lambda with a DynamoDB table. The GraphQL endpoint could use schema stitching to create responses for the client. It would talk to multiple microservices and put together an appropriate response for the client. Now, an interesting element of this architecture is that we were still using Google's Firebase database. Now, Firebase, as I said, was our original Firebase, and it has a fantastic property, is that it can connect to clients directly and kind of stream data using WebSockets. And as we implemented our microservices approach, we left Firebase in place. We didn't need to rip it out. We used DynamoDB streams to capture events and intelligently update Firebase and Algolia as we needed. So we could still maintain that great up-to-date user experience and migrate slowly, carefully, and thoughtfully without having to do an entire database migration upfront. And you can actually think of that Firebase database as a materialized view of our Dynamo databases that powered the user interface. I actually have another talk that describes how you can implement your own version of Firebase using Dynamo, Lambda, and API Gateway. So if you are interested, it's a fun talk, let me know, and I'll give you a link. And one thing that I love doing is showing what was happening to our system at that time. So this is around July of 2018. Our system had 289 Lambda functions grouped into 19 microservices. We had 3.7 terabytes of data in S3. So in that month, July, we did 107 million Lambda invocations, 45 million API requests via API Gateway. We had an egress of 3.8 terabytes of data daily. So these are videos that are going out that people are watching. And we had 650,000 users on the platform. By the time I left last year, we got to a bit over 2 million. And this was our bill for July, right? And just remember, and by the way, I've left the company, so it's fine. I'm sure it's fine to share this. What could possibly go wrong, right? Is this being recorded? Excellent. And just remember, this is 2018, and one good thing about AWS is that it never really raises prices, so maybe our bill today for the same usage would be lower, I don't know. And I should mention also that for the first 2 years, we paid nothing. We paid nothing for compute and API because we were entirely within the free tier that AWS provides, and it was kind of amazing. We had virtually no infrastructure cost. And that actually helped the business succeed. Now, the cool thing was that our serverless system worked, right? It was cheap to run, it supported our users, and because it powered our website, which had bursty traffic patterns, it was a perfect fit for us. And as we moved forward, our teams further evolved our architecture. We added service discovery, so the GraphQL endpoint could now find out which microservices to query. Things became even less coupled, I would say. And I should mention that the service discovery mechanism was built in-house. I cannot speak for our team right now, but maybe they would use something like AWS Cloud Map if they were doing it again. I don't know. It's actually kind of interesting that a cloud guru stopped being a fully serverless company. So we acquired our competitor called Linux Academy, and we integrated their product, which allows our users to create sandboxed environments of AWS. Now, this was actually implemented using containers, so running on ECS, and it was carried across to a cloud guru. So after the acquisition, technically, a cloud guru probably couldn't call itself a fully serverless company that only ran on Lambda. But let's not tell anybody that, right? I mean, we're all friends. Let's keep it a secret between us. So it's fine. So look, we moved from a serverless monolith in 2016, where all Lambda functions read and wrote to the same Firebase database, to a distributed microservices approach in 2018 to really a state-of-the-art serverless microservices system with service discovery and all kinds of bells and whistles a few years later. And I want to contrast this to the story about the Amazon Prime team, because both companies went through iterations of the architecture. Both companies had a vision, both companies had a goal, and I think both companies ultimately arrived at a good destination. Last year in February, after the acquisition of A Cloud Guru by Pluralsight, I left the company and set out on my own. Oh, brave new world. First, I worked on a fintech app that was called Spark. So Spark is a wealth management platform that helps you track finances, understand budgeting, make better financial decisions. And it was all serverless, and I think it was awesome. It is awesome. I've given a few demonstrations about it and discussed some of the architecture I developed for it. But I didn't even get to launch the product, or at least not yet, because Sam Kroonenberg came to me with the idea to start our AI incubator. And honestly, it was such an enticing offer that I just could not say no to him. So Sam and I, we began our incubator, and we are focused on releasing our first project right now. So what I want to do now is tell you what has worked for us at A Cloud Guru as we scaled up from a startup, well, went from a startup to a scale-up with millions of users. What worked for me building Spark, and what's working for us in our incubator right now. So for A Cloud Guru, for our AI incubator, we decided to go serverless first. And going serverless first allows us to iterate really quickly. It's the fastest way, I think, to get to market. So although, interestingly, our first product that we're about to launch, and I'll talk about that in a second, we use a whole bunch of containers as well, because we are running a whole bunch of ML workloads. And this is fine too, right? We are choosing the right tool for the job. And my suggestion to you, go serverless if you can, and if that doesn't work, then explore other options. Although, as you saw with A Cloud Guru, we supported millions of users, and we remained primarily serverless pretty much throughout, that little container thing notwithstanding. At our incubator, we have 2 developers, and I am one of them. So we don't have time to build everything, nor do we need to. So we have to use other services, AI models, and third-party products to move quickly. We need to focus on what makes our product unique and not re-implement things like authentication or data storage or orchestration code. So my goal is to leverage as many AWS and third-party services as I can. If certain problems have been solved, I want to use those solutions and not build another authentication system. Although, if you're thinking about adopting a system that rhymes with Magneto, maybe explore other ones as well. I'm sorry. This is the... Sorry, Derek. We are small, and what differentiates us, what will differentiate us, I think, apart from solving the problem that we are trying to solve, is presenting the user with a magical user experience. And I will talk about that in a moment, what that is to us. And finally, I wanted local development and debugging to be as easy as it could possibly be. Less friction in the developer experience, makes me a happy boy. So look, yes, our AI incubator is a serverless company. We are completely greenfield, which makes it easier for us to pick and choose which technologies we use. I understand that. I know that a lot of you may not have the same luxury in your workplace. But here are the core technologies that we are using in our incubator to build products. So yes, of course, we use Lambda. We use step functions, express workflows. I used a lot. API gateway. We actually use WebSockets for communication between the client and the backend. And WebSockets provide for a really nice user experience with very little overhead, apart from the initial kind of connection that can be done in the first second. We use DynamoDB, of course. I've been a big proponent of single table design. I don't know if I really believe in it these days. I think at least when you are in the exploration phase of your application, it doesn't make much sense because you don't yet know what access patterns you will have. And I think your access patterns will actually evolve and change. I think obviously if you have a static system, then single table design could work. We use Event Bridge for communications. So we never have Lambda to Lambda calls. We just don't allow that. If we need to do something like that, then we put Event Bridge in between. And of course, we use S3 for storage, obviously. Now, to help with the implementation, we use the Serverless Stack framework. We use it instead of SAM. We use it instead of Serverless Framework, instead of Terraform or CloudFormation. So as an overview, if you're not familiar with this framework, it provides an easier way to do local development and debugging. It is built on top of CDK. It has a console for administration of your resources, some higher constructs like function and config to help you kind of do things even easier, and other interesting features like built-in authentication. I just mentioned CDK, and if you're not familiar with what that is, it stands for Cloud Development Kit. It's a project run by AWS, and it's basically a way to define your cloud infrastructure in code. So you use CDK with regular programming languages like JavaScript or C# or Go, and define your infrastructure. You can use regular programming constructs like conditions, loops. You can build unit tests, whatever. So SST builds on top of the CDK, which you can also use directly if you want, but it provides a few additional niceties to make things better for serverless applications. And my favorite feature that I talk about a bit is that of live Lambda development. So SST allows you to debug and test Lambda functions locally while they are being invoked remotely by AWS. And the way it works is that it proxies requests from AWS straight to your local machine. So you don't need to mock any AWS services that your Lambda function uses. You don't need to use local stack or anything like that. You don't need to continuously deploy functions to AWS. So SST deploys little stub Lambdas into AWS and creates a WebSocket connection from AWS to your local machine. So whenever another AWS service invokes one of the functions in AWS, the request is proxied to your computer, your local function runs, and after the execution, the response is proxied back up to AWS, and everything continues to run. There is a DynamoDB table that keeps track of connections and an S3 bucket as a temporary storage if the request response messages are too large, but this is all handled for you automatically and seamlessly, and you don't need to know about anything really. And so the thing that I have on screen right now is an image that I took from the SST website, and you can see two stub Lambdas in AWS that are proxying requests to your machine and then back up again. And in practice, this works very well, right? I can save a function locally. I don't need to deploy it. The only time you deploy is if you go to production or if you are actually creating the function for the very first time that creates the stub. And if you use something like Visual Studio Code, you can put breakpoints in your Lambda functions. You can inspect local variables. You can step through your code. This makes debugging work the way we've been used to for years. And in a way, I feel like we've gone full circle. But anyway. Obviously, a function executing on your computer is a little bit different to executing in Lambda. For one, you have more memory, you have more CPU, but if you're fixing logical issues, syntax errors, then what does it matter really, right? The experience I get locally is amazing. I can save, I can put breakpoints, step through the code. It just makes my local dev issues a lot simpler. I love it. So we spoke about local development and debugging. What about observability and just knowing what's happening within your system? Obviously, you can use AWS services like CloudWatch and X-Ray. They are built in, and let's just say that they are OK. I think a lot of us have had a lot of experience using those tools. So another tool that I use is Lumigo. It's a nice product. It hooks into your environment, pulls data, and actually presents you with useful and actionable insights. And when things fail, like your Lambda function throwing an unhandled error, it's OK. You'll get emailed. the way issues are grouped is interesting, and I think really the main advantage of using this tool is that you can find things a lot quicker. So I'm not affiliated with them in any way. I'm just showing you what I use because people ask me. But look, there are many other interesting and useful products that you can explore as well. So our goal at our Hard Hands Incubator is to develop products with incredible user experiences, something to elevate the experience beyond what we're used to. Yes, we do use large language models, LLMs, to help interact with the user or move the user through the application in a more contextual way. So the ability to contextualize what the user is trying to do and instantly create the right experience or language or interaction is incredible, and it actually works very well. And we use LLMs, and you thought Keynote would not mention ChatGPT, right? Come on. So we use LLMs like GPT 3.5 Turbo, GPT-4, DaVinci. We use image models, we use voice models, and so on. So we work with text models like DaVinci and chat models like ChatGPT using Microsoft Guidance. Microsoft Guidance is a language that lets you direct and constrain the output produced by the LLM. So it works better at this stage with text LLMs like DaVinci, because you can specify a particular response structure like JSON, and Microsoft Guidance will go out and fetch the right values and properties as needed. It may even do multiple requests to the LLM to get all the values. But the effect of this is that, yes, you are guaranteed to get back a structured response that you actually expect. Now, it doesn't work as well with chat-based LLMs like ChatGPT. There's no capability for partial prompting in ChatGPT, so it's hard to enforce a defined rigid structure. Of course, you can use one-shot prompting or n-shot prompting to suggest a structure that you want to get back. But as we all know, you're not really guaranteed to get back a particular response. You can ask for JSON, but you may get back a truncated JSON, so who knows? If you are interacting with OpenAI models and find them slow to respond, consider going through Azure. It may be a little bit faster. And my God, I'm hoping that Amazon Bedrock is released or that I at least get access to it. I'm interested in the promised support for the Anthropic LLM. So if anyone here can get me access or help me, please let me know. We use models and image generation models. There are a whole bunch of services right now that make things easy for you. And we obviously wish that something like Midjourney had an API. It doesn't. So at the moment, we run our models for image, for voice, in containers. And we use a service called runpod to run and orchestrate containers. I'm sorry, AWS, but runpod beats ECS, Fargate, or anything else. So runpod can run containers on a GPU in a serverless manner. Now, Fargate still doesn't support GPUs. It's been an open issue since 2019. From memory, it's issue 88. So if you wanted to run containers on AWS with GPU, you'd have to get permission to use P-class instances. You'd have to provision P-class instances. You'd have to do all kinds of extra things to set them up. And it's just more of a hassle. So please, AWS, fingers crossed, Fargate, GPU. I'm sure it's coming. Derek is smiling at me, so maybe. But the nice thing is that everything can be orchestrated and managed by step functions. So our central orchestrator is implemented in step functions. And I have 1 minute left with 1 slide to go. I think we can do this, people. So I often think of a talk given by Tim Bray from a few years ago at reInvent. Tim defined a few high-level rules for modern applications. So he said that think about security and compliance first. That's the #1 job. Use microservices. Go serverless where possible. Have a robust CI/CD pipeline. Monitor everything that you are doing. So all these talks are given in the talk by Tim. That's the link. Please check it out. It's actually brilliant. Those are good calls, and I agree to a large extent. But I want to give you kind of my opinion as well. So first, on the issue of microservices. I don't necessarily think that microservices are appropriate in all situations. I think the answer there is that it depends. For applications at scale with multiple teams, multiple bounded contexts, a microservices approach is probably the right approach. But look, if you're working on a smaller project with a narrow bounded scope, if you're a startup wanting to get to market quickly, then a serverless monolith is not a bad idea. I know I was very dogmatic when I was younger, and I genuinely thought that, yes, microservices all the way, they are the answer to everything. But look, having seen a whole bunch of projects, large and small, succeed and fail, I really don't think that now. Your context and your goals matter a lot more. Automation is a must. Serverless systems are distributed systems. If you are using AWS, you're dealing with other services apart from Lambda. Maybe you have some non-AWS services as well. Soon enough, you'll have hundreds of interconnected moving parts. So if you do not automate deployments, upgrades, monitoring, the complexity of the system will crush you. It will get to be too much. So automate everything from the very start across all your environments and keep on top of it. Testing of cloud-native applications, particularly the ones that use multiple AWS services, Lambda, third-party services, can be tough, right? Things are definitely getting easier year by year, but you still need to think how you will build unit and integration tests. Look, it's tricky. Maybe using SST to test and debug is OK, and then having a solid unit strategy to back you up is kind of what you need. Next on the list, something we've discussed already, going serverless will help you evolve your architecture down the road. It will not be easy, but it will be easier, I think. So you can get to market quickly or quicker, and then iterate and get the kind of architecture that you need to scale, that you need for the scale you need to support. And I think that, look, I have a serverless first approach, which does include using third-party services and SaaS products. And if that doesn't work for me, fine. I can build a solution with containers. I can explore a hybrid solution, maybe something else entirely. My technical decision-making framework allows me to make choices quickly, but I'm never blind to changing requirements, scale, price, or performance. And you too should have a technical strategy that works for you and lets you evolve your architecture, your design, your application. And with that, I want to thank you for listening to me. I'm obligated to share my book one last time. My publisher will kill me if I do not. I do want to thank my co-authors, Jan and AJ, who are brilliant thinkers and know way more about serverless and microservices and architecture than I do. And I just want to mention another book called The Value Flywheel Effect. So it was co-authored by David Anderson, Mark McCann, and Michael O'Reilly. And it's really a serverless book for the managers and business people. It's about innovation and disruption and how to navigate the modern cloud. And look, it has a massive case study on a cloud guru as well and how we built our business. So please check it out. Thank you so much.